Okay, so now I think I'm really ready. I've started also the recording of the lecture. Today is the 2nd of April. This is lecture number 10, and I think the lecture will be something shorter than what I've written here in the first slide. Something to start. This is the material. I've simply added the last lecture dedicated to wood-based panels, and nothing more. I would like just to remember that some videos are now in my YouTube channel. And so, in order to see the video or to download it, we have simply to open this file inside the Dropbox folder and connect with this link to my YouTube channel. And so there you can find everything. This is the plan for the next lectures. Next one will be the 7th of April with the exercise we have planned, and the next Friday we will do the first written test. Next Wednesday I will give you some instructions for this test, and we will do also an experiment to see if the system I've prepared works properly. What about for the rest? Nothing to say about the exam. And this is the revised plan for your seminars. There is a new one, is number 11, about additive manufacturing from Anita and Akan. For the rest, I think there are still some open subjects, but I think the subject proposed are interesting, are very different with the subject related with wood, with products derived from wood. What else? Recycling, building material. So many interesting subjects related to our main subject.
Excuse me, Professor.
Yes, please.
Yeah, I have sent you an email the last week for me and my team, but I have not seen my name, well, our name on the list. I'm Destro Francesco.
Okay, I will check. Sorry, maybe I simply forgot to insert. I will do for the next time. You will see your names in this list. So the number is now 12. Very good.
Okay, thank you.
Okay, you're welcome. So what are we going to do today? I would like to finish the part dedicated to formaldehyde. Then, as I said, we will consider again the special terms I've used in the presentations dedicated to wood-based panels. And finally, if we will have enough time, I would like to finish the part dedicated to my tips for presentation. If there is no time today, we will do next time. No problems for this part. So let me open the presentation dedicated to formaldehyde emission. Okay, here. And here. Okay. So last time we have learned, I think, a lot about this problem of formaldehyde emission. We have learned what is this substance. Substance is, I just remember, is a gas, very reactive and with very good biocide properties. So in many industrial sector, it is used because, or it's better to say, it was used a lot in the past because of its preservatives and biocide function. And it was used, and it is still used today in the preparation of many chemicals, many polymers in particular, because, as we said, it's a reactive molecule. So chemists like me like this substance because we can build more complex molecules starting from this little formaldehyde molecule. So these are the sector where this substance is used: medicines, adhesives, preservatives, explosives, dyes, and many others. We have understood also that formaldehyde is present more or less everywhere in the air we breathe, and we have also considered that this substance is really present in very small concentration in the air, but we breathe a lot of air during our daily life, and so also little concentration, but continuously introduced in our body can produce some disease, some problems, some health effects on our organism. So the fact, the evidence that formaldehyde is toxic, is irritant, but moreover is carcinogenic for sure. It's clearly an evidence that the emission, the presence of formaldehyde in our houses, in the environment where we live, is a serious problem for all of us. We know now that formaldehyde is used also in the furniture sector for the production of different types of products, adhesives, coatings, polymer dispersions, as impregnation in the production of impregnated papers, of laminates. But the most important sector where formaldehyde is used is that of the production of wood-based panels. All panels we have already analyzed, they are based on wood, of course, in different forms, and a binder, which is normally an urea formaldehyde resin. We know now that urea formaldehyde resins are produced starting from these two molecules, the two substances, formaldehyde and urea. They are mixed together with some catalyst, with the contribution of temperature and pressure. And the result of the reaction is the polymerization of these two substances. So they produce a polymer that is used for the production of wood-based panels. There are two problems we said related with formaldehyde. The first is that not all formaldehyde which was inserted inside the reactor, not all the formaldehyde react with urea. So some formaldehyde molecules remain as free molecules inside the resin. But the most serious problem is the hydrolysis of the resin. So it means that the rupture, the breakage of the resin molecule induced by water, and water we know is present in the air of our houses. So these molecules can react with the resin which is present inside the panel, producing this cut of the chain, and the byproduct is formaldehyde. So we said that if we analyze the theoretical emission of formaldehyde from wood-based panels, we have these two contributions: the free formaldehyde and the formaldehyde which derives from the hydrolysis. And the red curve you can see here is the representation of the total emission, the global emission of one panel. What tell us this curve? This curve tell us that in the beginning we have the sum of the two contributions, the free formaldehyde and the formaldehyde deriving from the hydrolysis. During the following days or weeks, this curve reaches a sort of constant value because the free formaldehyde is lost. But the hydrolysis, we said that it continues for all the life of the panel, with a little decay of the time, but this curve tells us that the formaldehyde emission is a never-ending story. It's continuous for all the life of the panel and of the derived product like furniture. This is a typical example of an analysis carried out for this formaldehyde emission. You see here that after around 400 days, the emission is more or less constant. How can formaldehyde be measured? I said that we started. When I say we, it means the international organization which deal with such subjects. We have considered the limit suggested by the World Health Organization in 1989, and we have decided to measure formaldehyde emission producing a little house in our laboratory. So we have in our laboratories such chambers which reproduce the conditions of a real house. With certain temperature, certain relative humidity, with a certain air exchange, and with a certain load, which more or less reproduce what we normally have inside our houses. So what we measure here inside the chambers is more or less the same value that we can measure inside our houses. I've added that there are also other test methods which are quick and cheap, because especially the furniture manufacturers or the wood-based panel manufacturers need fast and cheap methods to control their production. Today, if you visit the producers of wood-based panels, if you can visit a plant, there is in all cases a laboratory like this, where they test continuously the formaldehyde emission of their products. Very often the laboratory is working 24 hours per day, because they need continuously to check their production. So this to check and to adjust, because they carry out the test, and according to the results, sometimes they have to change the parameters of the production in order to reduce the emission. So the formaldehyde control is something which is carried out continuously in all factories producing wood-based panels. Which are the limits? As I said, the limit for the chamber is the same limit that was established, that was suggested by the World Health Organization. So it's 0.124 milligram per cubic meter of air. And in Europe, such panels are called E1. There is a standard which define whatever I already said, but what is important is that in many countries in Europe, this class is mandatory by law. For example, in Italy, but there are other countries. In Denmark, in Sweden, in Norway, in Austria, Croatia. There are many countries where this limit, this class, E1 class, is established by law. In Italy, this decree is in force since 2008. I've mentioned that last year there was an important news from Germany. In practice, they have reduced the limit by the 50%. In practice, the limit is the same in their law, in their new law. But as you see here, the results of the test must be multiplied by a factor 2. So it's like to say that the limit is exactly the half than before. This change, this variation of the German law is consequent to some studies carried out by the experts of this country, which has considered that today our houses are smaller. The air exchange is reduced because of energy saving. And so the values defined 30 years ago for the chamber method, they said, are not valid today. Today, our apartments are very small, with a lot of in the same room. We have the kitchen, we have the bedroom, we have the dining room, and so the presence of furniture is much more important today than in the past. And again, the energy saving laws limit the air exchange in our houses. So the pollutants can stay inside our houses for a long time. This is not valid only for formaldehyde, but for all other possible pollutants that we have in our houses. So the suggestion is to open the windows very frequently, not only for the chemical pollutants, but also for the biological pollutants. And we know the story of the virus. So one way to limit the contamination from chemicals, from biological or semi-biological species is to open the windows. Remember that is a simple action which can save us from problems deriving from the contamination we have in our houses. Going on with the limits that there are in the different countries, an important law is that established in 2009 in California. I think you know that California is very sensitive to the environment. Is a reference country for the prevention of pollution, the prevention of the air contamination and so on. So they started in 2009, and in 2018 the California law became a federal law. So today is valid in all the USA. It's a particular law. They have a different chamber. The method that is used is very similar to the European one, but there are some differences. For example, we use 23 degrees in our chambers. The American method use 25. We use 45% of relative humidity. They use 50%. So they are not different in the principle, but they differ in the parameters. So it's a complication also for the laboratories, because we have to deal with different test methods. In practice, they are similar, but we have to change the parameters of the measure according to the destination of the product. They have also different limits for the different type of panels. This because they started with the mobile houses problem. Many years ago in the United States, there was some serious problems for two hurricanes. One was the Katrina hurricane, and the other I forgot the name. So the population they have lost their houses, and the state provided these mobile homes for them. After some days, they discovered that such mobile homes were full of formaldehyde. It was a real scandal at that time. And they have considered that this mobile home were produced with different types of panels, particle boards, MDF, plywood, but in different quantities. So the limits you see here reflect the amount of the different type of panel which were present in the mobile home after the hurricanes I've mentioned. Plywood was the main material with which mobile homes were done, and so for plywood the limit is it's very low. For the rest, you see the limits are higher. This complicates more also the analysis, because you have to use a different method than the European one, and also the limits depend on the type of panel you are analyzing. The American scheme for the analysis of formaldehyde in wood-based panels is really strict, because all the panel manufacturer that export their products in the United States, they must be controlled by a third-party certifier, so it means by an external body, with audits to be done every 3 months. So it's a really strict system. We are as CATAS, we are authorized by CARB and EPA to carry out such controls, and my colleagues are continuously involved in such activity, because as it's written here, every 3 months you have to go to the factory. You have to check the process, if something has changed. You have to sample some panels and to test inside the lab. So also in terms of cost, the certification according to the American scheme costs around I could say 10,000 euros for one production every year. So it's a real problem for this sector. And today this American scheme, because it's as I said, the most strict, it is the scheme adopted by IKEA. I've mentioned, I think, many times this Swedish company. It's I think the leading company in the furniture production in all countries of the world, apart from China. And so what IKEA decides as an immediate effect on all the furniture sector in every country. So today all the panels used for the production of IKEA furniture must be certified according to the American scheme. And so you can imagine how dramatic is in terms of activity for the wood-based panel producers, for the furniture manufacturer, and also for the laboratories like us. There is a lot of work to do continuously, and a lot of visits inside the companies. So it's a really it's a system that is having a strong impact in the furniture sector, and the reason is the one I've already mentioned, because it is the scheme defined by the United States, but is also the scheme adopted by IKEA, and IKEA today is a leading company of our sector, and what they decide as a strong impact in all countries, in all furniture manufacturer, and so on. There is also a law in Japan. They have another type of chamber, another complication, or a more simple method called the desiccator. They have divided the panels in 4 classes. It's a standard which is valid not for furniture but for buildings. And in the standard they say that if your panel is classified as F4 stars, which is the best, you can use the amount you want inside every environment. There are no limitations. If the panels are classified F3 stars or F2 stars, you can use them, but you have a limitation according to the volume of the environment where such panels will be placed. So if you want to use F3 stars panels as ceiling, for example, you have to calculate the surface of the panel, the volume of the room, and there are indication, there are limits for this ratio. F1 stars are banned. You cannot use F1 star panels for Japan. So these are the main laws that presently we have to deal with. As you can understand, it's a really complicated to know all this story, because we said that there are limits for some European countries. Germany has its specific limits. United States, completely different test methods. Their schemes involve a certification with audits and so on. In Japan, there are another type of system with the different classification, different test methods. So it's really complicated to work with formaldehyde in the furniture sector. But as you now know, every company, because wood-based panels are used for every type of furniture, so every company in the furniture sector is involved in this subject of formaldehyde emission, and they have to deal with this different law, with these different test methods, and so on. So it's a complex subject. These are some comparisons, because you could say that, okay, let's use the one type of panel which are good for every country, but you see that, for example, for particle board, the Japanese is the lowest, the FO star is the lowest value. For the rest, the German are the half of the E1 class. They are a little bit lower than the American. If we go to plywood, the situation is different, and it's different again for MDF or for thin MDF. So it's not easy to deal with such a subject because of the reason I have already mentioned, and because of the evidence you have here about the comparisons of the limits. In France, they have a decree for all building materials. They consider the quality of the air inside houses, and every building material must be classified according to this label. Class A plus is the best, and class C is the worst. So if you go in France and you buy every paint, for example, for walls or flooring or whatever material which can be used for the construction of an house, it must be labeled according to this scheme, which contains also formaldehyde as a reference substance. There are also others, toluene, xylene, and other solvents. But also formaldehyde is considered. Some months ago, I went to a shop here in Udine, and I found some products with such labels you see here. So it's something maybe you can find also in your countries. So this is an evidence of the growing importance of the emissions of not only formaldehyde, but emissions of all the volatile organic substances in the air of our houses. And it is testified by this label you can see on different types of products. Another one here, it was the same shop, and this is a paint for walls with the same label. So this gives you an idea of how important is becoming this subject of emissions inside our environment, living environments. There are other laws we will see not only in France but also in Germany, in Belgium, for building products or directly for the air of the environments where we live. This is the Belgian decree. Again, you see that formaldehyde is considered in the different types of substances which are limited for building material. In the next future, maybe we will have a label that like this one, a European label, again, for all buildings material, and also formaldehyde will be for sure considered. The CE marking of building products, which is mandatory in Europe. I think in the next 2-3 years, 5 years, it will also contain such label, which will inform all the population about the safety of building products in terms of emission of volatile substances. This is a subject that must be considered, is a part of our future. The quality of the air we breathe, it's something growing, and not only the furniture sector, not only the building sector, they have to face with this new important requirements of the safety of the air we breathe inside houses, schools, universities, restaurants, and so on. The last part is dedicated to the possible reduction of formaldehyde emission. What are the possible strategies? The first is it's very simple. The most simple option is to reduce the amount of adhesive inside the panel. It's very easy in principle. The problem is that if you reduce the amount of the adhesive, you reduce consequently also some of the properties of the panel. In particular, the mechanical property, the internal cohesion can be strongly affected. So in principle is right, but in practice it could produce serious problems to our panels. Use of melamine formaldehyde adhesives or combination. Melamine when react with formaldehyde produce chemical bonds which are more stable to hydrolysis than the same bonds produced with urea. So melamine formaldehyde resins are absolutely better than urea formaldehyde resins. You could say, okay, you have found the solution. Why not to substitute urea formaldehyde resin with melamine formaldehyde resins? The answer is that melamine formaldehyde resins costs around 5 times more than urea formaldehyde resin. So also in this case, in principle, we can substitute urea formaldehyde resins with melamine formaldehyde resin, but the cost of the panel, the cost of the finished product will increase a lot, and so it's something that is not so easy to be adopted. I forgot to write here that there are other types of resins that we can use. For example, today there are many experiments, but also applications of resins derived from vegetables, especially from soy seeds, which seems to be good, not only in terms of performance, but also in terms of costs. So today you can find on the market some, especially plywoods, produced with this soy-based adhesive, which is not only good because of the absence of formaldehyde, but it's good also because it's sustainable, because the resin is produced from vegetable seeds, so we can consider what we said at the beginning of our course about sustainability. So this is a good way to enhance the sustainability of the products. The problem we have with this type of natural adhesives is the resistant to water, resistant to humidity. This could be another subject for your presentations. The use of natural or vegetable-based adhesives for the production of wood-based panels, the good and the bad. I think you can find, you could find many publications, many references. Also, some companies which advertise the production of panels using such adhesives. You can find a lot of material, maybe also with an interesting also possible development of such market. Another way to improve the stability of your formaldehyde adhesive is to work on the molar ratio. It means on the ratio of urea and formaldehyde when they are mixed together. In principle, it's something which produce good results, but reducing the amount of formaldehyde in the combination of the two substances reduces also the reactivity of the resin. So, for example, the pressing time must be increased. So there are some consequences, negative consequences on the final product. And finally, this is something that is used a lot today. The use of scavengers, formaldehyde scavengers. They are special substances which are added to the panel during the production, and they react with formaldehyde immediately after it is formed by the hydrolysis. So they prevent the emission of formaldehyde because they immediately react with formaldehyde. Immediately after it is produced by the hydrolytic reaction. So you put these scavengers inside the panels. When formaldehyde is formed, these scavengers react and they block the formaldehyde emission. They stop the formaldehyde emission. Normally, when I present these scavengers to for example, to the furniture manufacturer which are not familiar with chemistry, and I normally say that such scavengers are like little soldiers you put inside the the panel, and so when formaldehyde is formed, they with their guns they kill formaldehyde, and so formaldehyde is not emitted. So it's something good way to prevent formaldehyde emission, not the formation. So you don't affect the glue, you don't affect the mechanical properties of the panel. You simply add something which react with formaldehyde, so it prevents from the emission of this substance. I think that yes, this is all for this part. I've the last slide is this one. Considering that we breathe around 500 liters of air every hour, and considering that in our environment there is formaldehyde for sure. If the concentration is exactly equal to the limit recommended by the World Health Organization, this means that we have inspired in 1 hour something like 0.06 milligram of formaldehyde. So inside our body, 0.06 milligrams were able to enter inside my body, inside your body, okay, let's hope that such substance did not create problems to our body. Some people could be, as I said, more sensitive to such substance, and maybe if some of you is allergic, has some problems with such type of disease, it's something that you could consider, because as I said, it's apart from the carcinogenic effect, but it's irritant, and so if you are particularly sensitive, you could feel, and your body could react to the assumption of formaldehyde with bad effect for you. I think this is all for this part, and before we finish the lecture for today, I would like just to consider the terms. Just a moment. Okay. So I've listed here the terms we have used for this second subject, wood-based panels. So I would like just to read them and to clarify what is their meaning. Wood-based panels, I think we don't know to explain that our panels produced with wood. Unitary elements are the elements which form the panel we could have particles for particle boards, fibers for fiber boards, veneers. Veneers, remember, are thin sheets of wood, thin foils, which thickness in the case of plywood is normally around 1-2 millimeters. Then we said that in the second step we use the thermosetting resins. Thermosetting means that they set in consequence of heating. Means that they harden, they became solid in consequence of heating. This is a big difference from the thermoplastic resins. We will consider later on more in detail what are the differences between thermoplastic and thermosetting. But just to give you a general idea, I would like just to remember that thermoplastic, we have used this term for lignin, is a polymer which became soft in consequence of heating. Thermosetting are on the opposite, are polymers which became more hard in consequence of heating. So the behavior is exactly the opposite. Thermoplastic became soft when heated. Thermosetting became hard when heated. And the main use for the production of wood-based panels are those known as urea formaldehyde, which are the two monomers used for the preparation of the polymer. Melamine formaldehyde, we have already said that they are absolutely better in terms of performance, in particular the resistance to hydrolysis is higher, but the cost of melamine formaldehyde resin is I said 4 or 5 times more than urea formaldehyde resins. In consequence of the evidence that melamine formaldehyde resins are resistant to hydrolysis, this type of resin can be used for panels, especially solid wood panels or plywood to be used outdoor. So you cannot use outdoor panels produced with urea formaldehyde resin because of the problem of hydrolysis. They are destroyed by water. Melamine formaldehyde resin are more resistant to hydrolysis, and so this is the reason why from one side they emit less formaldehyde, and from the other they are suitable also for outdoors environment. Phenol formaldehyde, also in this case, the performance are very good, also outdoors. The problem of phenol formaldehyde resins is that phenol is again a dangerous substance, and the other problem is that the bonding line is dark, is brown reddish, so the panels produced with such raising present this dark color in the bonding line. And apart from this, phenol is a serious dangerous chemical, and so they are used for certain type of panels, in particular for plywood to be used outdoors, but the use is really limited. We mentioned the possible additives to be added in the production of wood-based panel. We mentioned hydrophobic substances like paraffins. Hydrophobic, I said that hydro means water, and phobic means fear, means dread. So they don't like water. This is more or less the meaning. So these are substances which are added to certain type of panels to protect them from water. So you can find particle boards that are called sometimes hydro particle boards. In any case, they are classified according to certain standards. And such panels contain such paraffin to reduce the effects derived from the contact of such panels with water. And the use of such panels is recommended, for example, for kitchens, for bathrooms, for environments where humidity or water is normally present. We mentioned also fire retardants. We can add such substances to wood-based panels for certain applications where we need to reduce the fire sensitivity of wood-based panels. So in Italy, there are laws for public environments like theaters, like restaurants, like hotels. So in that cases, the use of wood-based panels containing such retardants is mandatory. The laws on fire resistant are different in every country. Also in Europe, in principle, we are in the European Union, but in many cases, the laws, especially those related with safety, they are different, and so there are not common rules in Europe or in any case all over the world for the fire safety in buildings. We mentioned solid wood panels, which are produced with little solid wood elements which are bonded together to produce, we said, wide panels, thick panels, or very long panels. They are used mainly, we said, in the building sector, but there are some applications also for the production of furniture. We mentioned tabletops, so it's the top of the table, chair seats, or profile, which are long and narrow elements used for different purposes. Then we analyzed the different types of panels, like particle boards, so boards or panels produced with particles. We said that it's possible to use different types of wood sources, not only trunks, but also sawdust deriving from other woodworkings. The residues of other woodworkings can be used for the production of particle boards. But we can use also what we called recycled wood. Last time we have also seen a video where recycled wood was used for the production of particle boards. The distribution of the particles inside particle boards is not homogeneous. Normally, there are three layers: the fine on the external layers, and the coarse in the internal part. I don't want to repeat why we have this distribution. I think I've already mentioned more times. For this reason, the density profile is I think I've said that it is like a sort of identity card of the panel, because many of the properties of the final product depends on the density profile, especially the mechanical properties. And very often the panel producers they continuously measure the density profile in the production line. So they have a special system using X-rays which are able to measure the density profile after the pressing, and so they can continuously adjust for example, the amount of the three types of particles. They can adjust the pressure. So it's a fundamental property of the panels. And what we said, it's also important the symmetry of the density profile, because if the density profile is not symmetric, so for example, if one of these two layers is lower than the other, the panel could bend in use, creating a serious problem to the final product. It's quite frequent the case where the doors of big wardrobes they cannot close, but also this happens for the little doors of the kitchens, for example, or bedrooms. So symmetry is a fundamental for the good behavior of the finished product. The internal cohesion, it's also a determining factor for wood-based panels. We will say something more also on cohesion when we will analyze the adhesives. Cohesion is the internal force which bond together the elements or the molecule of one material. So this is important. We said, for example, for the screws that are inserted in the panel, the force of the screw strongly depend on the cohesion of the panel. Then we analyzed very quickly the oriented strand boards. It's type of panels similar to particle boards. In this case, the particles are bigger. The typical applications of such panels is the building sector, but we said that in some cases they are used also for the production of certain type of furniture. Fiber boards are boards produced with fibers. The production process is similar to that of particle boards, but in this case, initially there is another step after the chipping of the wood. This step is called the defibrillation. So the wood cells are completely destroyed in consequence of some chemicals, some particular procedures involving pressure, involving steam inside this particular reactor. So it's like a little explosion of the wood cells, which are reduced in small fibers, and then the fibers are assembled together to produce the fiber boards with two different processes. The wet process is called wet because the moisture content of wood is higher than 20%. So in this case, the panel is produced without any external raising and without any external polymer. In this case, we said is the lignin that acts as a binder. So we know that lignin is a thermoplastic polymer. So when it is heated, it became soft. It becomes partially liquid, and so in this process, it acts as the binder for the fibers. The other process is the dry process. So in this case, the fibers are dried before the pressing phase, and not only dried but also mixed with the raising that is normally a urea formaldehyde raising. And the result of such a dry process is a fiber board which is known as MDF. So the three letters indicates a medium density fiber board. Then the last type of panel, plywood, which are made of different layers. In the case of veneer plywoods, the layers are veneers, which are pressed together with the different layers placed in the opposite direction. This improves the mechanical properties of such panels and reduce also the behavior, the anisotropic behavior of wood. They are used, for example, for the production of bed slats because we said that veneers, one of the most important characteristic of such panel is the good mechanical resistance, even in the case they are produced in thin layers. Finally, we analyzed the composite panels, which are made of different type of materials assembled together. And the most important type of composite panels are the honeycomb boards, which are made with 3 layers, 2 external covers made of particle boards or made of MDF, and the internal part, which is made of paper in the form of the honeycomb structure. We said that these are increasingly using in the furniture sector because the main property of such panels is the lightweight, and I don't want to repeat myself, but lightweight is today one of the most important properties of furniture elements, and the reason is because furniture are produced in one country and they are sold in another, so they travel a lot, and the weight is means cost. I don't want to mention too much time this Swedish company IKEA, but for what I know, there are 2 parameters they consider when they design a new model, a new type of furniture. The first is the weight, of course. So when they design a new cabinet, for example, they consider the use of materials with the lower weight. And the second is the dimension of the product, considering the container where it will be stored. So they try to design furniture in a way that all the container can be completely filled. No voids, because voids means space that is paid for the transport but not used. So the two parameters, as I said, that they consider, one is the weight and the second is the space. So the dimensions of their furniture, yes, okay, are studied according to the needs of the end users, according to the standards, but also considering the space of the containers where they are stored for the transport. So also this new target of the market sometimes are also interesting to be known. Finally, we have very quickly analyzed the different type of woodworkings that are carried out on wood-based panels. We said that sometimes, considering that considering that the furniture manufacturer, they buy wood-based panels that are already finished with the melamine paper. So they only need to cut the panel sizing. So I forgot maybe to write cut the panel, to drill it, creating the holes for the connection of the different parts, and we will see the closure of the edge. So in many factories, you can see only 3 machines, sizing, drilling, and the edge banding machines. So the machines used for the closing of the lateral surfaces after the cut. The rest are more complex woodworkings that are used by specialized companies. A quick mention about the difference between calibration and sanding. In principle, is done. The 2 woodworkings are carried out with the same machine. Calibration means to reduce the thickness of the panel to the desired value. Normally, it's carried out by sanding belts. And the sanding is similar, but the aim of sanding is produce a flat and homogeneous surface for the following finishing operation. So calibration and sanding are in principle are the same operation carried out with the sanding belts. But the first one, the aim is to reduce the thickness. The second is to create a homogeneous and flat surface. Finally, today, I think there is not much to say about such terms, because we have already repeated this morning. Formaldehyde, we know what is this molecule. Hydrolysis, I've already mentioned the meaning. Hydro is water, and lysis is cut. So it's the cut of the bonds of the urea formaldehyde resin, which produce as a byproduct formaldehyde. Cut is not the proper terms, is the degradation, is the chemical reaction. Such terms are more scientific than cut. E1 is the class defined by European standards for wood-based panels with reduced emission of formaldehyde, and the limit has been established according to the indication of the World Health Organization. The CARB and EPA are the bodies, the American bodies. The first one is the Californian Bureau, and the second is the Environmental Protection Agency, which have published specific laws in the United States for the control and limitation of formaldehyde emission from wood-based panels. So don't want to repeat all the story we have already discussed today. And finally, this strange term, formaldehyde scavengers, but okay, also this term I've already told you what the meaning of scavengers and why they are so important in the production of wood-based panels. Okay, it's 38 past 12. I think for today it's enough. Let me know if there are some questions from you. No questions? Are you breathing well in your houses? Yes, with open windows. Remember that very often it could be strange, but the quality of the air inside our houses is the worst than the quality of the air outside. Even if you live in city centers, very often what we have around us can emit dangerous substances, and so open the windows. You can feel this problem of emissions, especially when you enter in a new house or in a freshly restored house. You can smell what we normally call the smell of new. When you buy a new car, for example, also a new car has a very, very good smell normally. But remember that what you smell are solvents, formaldehyde, plasticizers, monomers. And so the feeling could be good, but the effect, especially at longer term, could be dramatic. Okay, so if there are no questions, we can close also this lecture. It was shorter than usual. If there are no questions, I could say only Happy Easter for the following days, and we will see next week. I recommend you to start to study something, because next week there will be the first part of the exam. So try to open the slides to see again the lectures in order to be sufficiently prepared for the first part of the test. Okay. For any question you may have, you can find me also during the next days. Unfortunately, we cannot travel. We are all of us we are close at home, and so for any reason, any question, you can contact me at any time. Okay. So bye bye.
Thank you very much. Bye bye.
Bye.
Bye bye.
One question.
Thank you. Bye.
Bye.
So, Professor, maybe one question.
Yes, please.
Could you maybe tell shortly some things about how the exam will look like? Some fellow students and I have been wondering about, or at least talking about, and we haven't been sure what kind of exam it will be. Maybe it's written for sure, but what kind?
I will explain next time, but in any case, I can answer you. It will be a written exam, of course. I will send you a file from Google. There is a special tool for exam. You will receive this module to be filled, and then simply clicking on one part of the module, we will send back to me. So you don't have to print it, you don't have to do anything. It's something you will receive by your email, It's a link. You will find the questions. You have directly to fill the answer and then send it back to me. There will be, I think, 5, 6 open questions related with the subject we have done until today.
Okay.
It's enough.
How long will be the exam?
I think that in 1 hour and a half, you could be able to finish. So we can also fix in 2 hours, but I'm sure that you are good, and in 10 minutes you will finish the exam. But 2 hours is good. There will be, of course, some rules. So you have to switch on your camera and microphone in order you don't speak with other students or you don't move away from the place where you are. But in any case, the questions are not simply a notion, so I will not ask what is a formaldehyde scavenger. There will be more, not complex, but there will be something you have to think about. Otherwise, you could go to the slides. You can copy and give me the answer. So it will be something different. So something you have to work with what you have learned. This is my intention. Okay.
Okay, thank you very much, Mr. William. And now having some nice Eastern as well. So see you next week. Bye-bye.
Bye to you.
I have another question.
Yes, please.
Regarding the recordings.
Yes.
I just looked at the last one, and unfortunately, it's only 15 minutes long. Yeah, the beginning, and then only 15 minutes.
So I will try to I take a note.
Yes. Just
Linlot, you just have to download it. 15 minutes is just an overview, and if you download, you can see it completely.
Okay.
Okay.
Thank you.
Okay, so this question is solved. Thank you.
Yes, thank you very much.
Thank
Bye.
you to you. So, in any case, I'm still here for the following 10 minutes. So if there are other questions, you can knock off on my video, and I'm here in my office till 1 o'clock. Okay.